Right, hello everybody. This is a bit of a monster of a talk because it has a lot of live demos in. So I will ask you to bear with me as I flip around all the time between, different windows. There we go. Okie dokie. So, hello, I am Andy. I like to break stuff and put it back together once I know how it's been working. I work at Control Plane, and I'm very proud to say that I'm a trainer for various organizations. That might disappear eventually. Watch out for SANS Sec 584, which is a cloud native security course, 5 days coming out next year that I'm pleased to be working with on. It's out of battery, marvelous. I'm a founder at Control Plane, which is continuous security engineering practices with a focus on cloud native and regulated industries. And I want to talk about container breakouts, Kubernetes break-ins, cluster drive-bys, API exploits, pwning everything that we can find, fingers crossed, and how we fix the security skills gap in the cloud native ecosystem. Spoiler alert, we do it by training the next generation of cloud-native security engineers and architects with production-like systems that they can hack, they can play CTFs until they can pop shells, and they really understand what they're doing. They test, remediate, and harden so we can hack back in. We do this with models that we build for the system. These are threat modeled attack trees. This is all open sourced under the Financial Services User Group in CNCF. And attack simulators, which are production-like infrastructure in safe testing environments. More on this later. So, what are we going to do? I've got some local VMs, I've got GKE, got some droplets, got some Docker versions and some kernel versions, and I will demo a hacking simulator right at the end if 30 minutes is enough. Also, I am drinking through this. Premature, perhaps, ladies and gentlemen. Okay. So what are we doing? Docker and Kubernetes. Do we love Kubernetes? Well, broadly, does it love us? Absolutely not. Why is it so difficult? It is a distributed system. We're all trained on monoliths, and all of a sudden, we have to deal with all sorts of different network-based problems. What is the problem with Kubernetes? Well, it's a layered security onion, but if I can get onto a single node, if I can root one of your workers, I can probably root your whole cluster. So, containers. Containers are awesome. We have to thank the hosts of this dev room for all the work that they put in, not only on LXD, but also upstream into the Linux kernel. But they emerged from the primordial kernel soup, a child of evolution rather than intelligent design that has morphed, refined, and been coerced into something usable. But don't forget, containers do not exist. They are merely the resultant bundling and isolation left once we've set up our namespaces and C groups and Linux security modules and started our precious little process inside. And finally, that being said, we love, oh, that is a shame because that is an amazing gift, Kubernetes. So this talk will go fast. There's lots of demos. I'll do my best. A prayer to the demo gods and an offering. Let's go. We all know this, right? We shouldn't run privileged, we should not run UID 0, and the Docker socket should not be mounted inside a container. Why is that, I hear you ask? Let's see. Okay, where are we? We are here, hopefully. Nope. We are here. Okay. So we are spinning up a container with a double hyphen privilege flag. What happens when we run privileged? Do you see anything in that list of mounted devices that we shouldn't do? Yes, that is the host device, dev VDA0 mounted with etc hosts on top of it. Why is that a bad thing? Because you can do as root inside the container, and importantly, there is no boundary between root inside and outside the container unless we have user namespaces enabled. What can we do? We can mount dev VDA1, and we can put that inside our container at any old mount point. And then what do we have there? Well, not that alias. We have the host's root file system. That is not a good look. Can it get any worse? Well, yes, indeed it can. Let's just leave evidence that Andy indeed was at one stage here. All right, and then we're back on the host. What are we going to do now? Have a look at the roots, and Andy was there. Who is that owned by, and when did that turn up? 1416 looks relatively recent, and that's not how you spell stat. Yeah, so that's a bad day. Do not run privileged. Having UID 0 inside the container is not a vulnerability in and of itself, but it leads to much easier privilege escalation if I can get inside your container. Okay. And those were misconfigurations, right? That's something that we can actually defend in the pipeline. So it's all very well talking about the problem. Let's talk about the fix as well. In the container's lifecycle, unit tests are kind of run in isolation, and I'm taking the test pyramid and I'm superimposing my own view over the top. In this case, unit tests are static or dynamic analysis on the container itself. Integration tests are probably more dynamic analysis inside the container, maybe akin to actually testing the public APIs of the application inside the container. Why is that important? Because the configuration changes with each environment that we promote it through. The container stays the same, but its behavior is dependent upon environment variables or config that we mount in, so we have to test an end-to-end test. Well, that's the full system, essentially. So what can we do for static analysis for Docker files? We can lint them, and we can determine whether or not we have done certain things wrong. Something that we can't do, or that is in fact very difficult to do, is identify which user was running, because that is a runtime construct, and we can switch users in the entry point, for example. So we probably, also you can do it for Kubernetes with sec, which is static analysis for Kubernetes resources. This will tell you, do not mount X, Y, Z, and it will give you a risk score to try and quantify the danger of running a particular configuration. There are lots of things that you can do in a pod YAML to break it. Right, so what about dynamic testing? Well, we can use inspec, it's heavyweight, it's Ruby. Do you want to install Ruby inside your container? Hell no. What about server spec? Well, it's still quite nice, but again, the same problem. It's Ruby, so what do we use? GOS, Go Server Spec. It is simple, declarative, highly parallelized, and written in Golang. What does that say? Cloud native, hooray. So, this is what GOS looks like. You have a simple YAML-based format. It runs everything with default with 50 threads or Go channels. And in this case, command is the type of test, and the key here is a version. So we're just making sure that our base container, we have a contract with it that it's shipping something to us. Right, obviously you can use GOS for anything and everything, and I recommend it to the house. What next? Let's break out of some containers. Who remembers Dirty Cow? A copy on write vulnerability in the kernel, which had been there since potentially 2007, version 2.6.22, and it's a copy on write race condition, whereby an unprivileged user is able to write into root-owned memory, execute it, and pop a shell. Exploitation of this bug does not leave any trace of what happened. It was detected by some dude running a rolling packet catcher on his honeypot, who then pulled out the binary and recompiled it. What a guy. Okay, why is it bad? It hoses your system. Containers in a default configuration at the time did not contain this bug. Containers rely on the kernel for protection. System calls from inside a container do not hit a local kernel. They are proxied onto the host. This is why the kernel isolation model is more difficult and nuanced than a VM, which has an entire full biosimulated version of the kernel running inside it. Instead of containers, we get the speed increase. We start our processes very quickly, but we pay this penalty of proxying system calls. If the container is reliant upon the kernel, and the kernel lets the container's guard down, we're having a bad day. There are ways around this. Let's have a look. Non-deterministic live demo. Woohoo. Okay, so on to Dirty Cow. So this may suffer slightly on this screen. My side vagrant already, yes. Sorry, that's rather unusual. Okay, so what are we going to do here? Start tmux. Sweet. Also, I managed to remove the U key from my keyboard, so you'll notice that I have trouble typing U. There was chocolate beneath it in a late night hacking session is my excuse. Okay, and what exactly happened there? Let's just run up to this. Okay, so what are we doing? We've got Docker at the top. We have sysdig twice. We have at the bottom temp.x, which is a lock file that the exploit uses to determine whether it's been run, because it's just spraying system calls, highly parallelized. It's a copy and write rate condition vulnerability, so we do as much as possible in order to break it. Sorry, this is going to have to go a little bit lower. The lolcat is not installed. I do apologize. Okay. Let's get into... Okay, do we want to proceed? Yes, please. There's a number of exploits suggesting that actually the kernel version we're using is vulnerable, but do we want to run with AppArmor? In this case, no, because we have a specific configuration that will fix it, and off we go. So we're just firing. Deadbeef is the exploit name, wonderful choice of hex value, and we're trying to patch the VDSO, the Virtual Dynamic Shared Object, which is kind of a proxy in user space to stop us having to hit the kernel all the time. And then we're trying to p-trace it, and at the point that we gain control of the process, then we inject our own code in. That will then, you see we've got a listener running here on logs to 1, 2, 3, 4 on the host, all the host adapters, and then once this thing kicks in, it will, so that host adapter is where the endpoint is in the VDSO, and once we pop that, we will connect from inside the container to that, and then we have root control of the host. As I said, this is non-deterministic. If it doesn't finish by the time I finish this sentence, I will come back to it because it will just have to be run in the background. Okay, you will have to take my word for that, and we'll come and have a look in a moment. Okay, so what is going on there? We're reliant upon the p-trace system called patch to VDSO. Let's keep it going like this. What just happened? Well, theoretically, we bypassed container security, but let's just see if anything's actually occurred yet. Yeah, there we go, hooray. So this claims, oh no, this is one still. Okay, it is non-deterministic. Let's keep on going. All right, so theoretically, we bypassed container security mechanisms. If we rerun that same exploit with a slightly modified AppArmor profile, different to the default one that Docker ships, to block ptrace calls from within the namespace, we effectively block this exploit, but the actual solution is to patch our kernels, as always, run latest versions of things. What can we do around this? There's various things here, but ultimately this is a sandboxing fix. There we go, hooray. Okay, so theoretically this has worked. You can see it's got patch 2 of 2. Because of the number of system calls we've made, the second window will keep on spooling ad infinitum. But here we should be root. Sweet. So you can see here that we've actually, that is on the host at the bottom. Now, because we were inside a container at this point, we shouldn't be able to see anything on the host. So what should we look for? Yes. Let's see if run C is there. If we are going to grep, we should probably use the word grep. And nope, because it's older than that. Let's grep for the Docker daemon. There we go. So we should not be... Yeah. Okay, obviously this kernel version is a few years old and I've had to keep this VM around. But what we see there is we're inside a container and we're doing stuff on the host. It's a bad day, container isolation is broken. Let's continue. So what do? We modify AppArmor seccomp profiles. We should be fine-tuning these things. Tools like Jesse Frizzell's Bane. There's loads of new eBPF-based seccomp tracing stuff that will extract seccomp profiles from running applications. This is all that the big container security tooling does for you anyway. Some bells and whistles, or as I heard it described, Belgian whistles around that. And of course we want to write effectively. These slides are available for posterity afterwards. 13 minutes. Okay, bypassing controls. What else are we going to do? Well, oh yes. Thanks, Jim. Some of these are just not loading in time, are they? Bypass container security controls. Oh, well, that does move eventually. So, there was an AppArmor bypass recently. This was quite interesting because... these are just not loading. Okay, we'll get there. Cool. So what we've seen here is we've just created a volume and put it over part of the proc file system. We shouldn't be able to do that. It was a bug. But this means that when the application looks for information as to what AppArmor configuration is configured, we've overwritten it and there is none. Sly little bypass. I don't know how long this was around for. Probably a good long time. Yeah. Proc self-exe. This one is fun. This is taking a symlink or a pointer perhaps back to the Docker run C binary from inside the container, overwriting it, and popping a shell. And I will attempt to demo this one. Where are we now? And this, as I said, will carry on ad infinitum. Yeah, yeah. Okay, where are we going? So let's go here. So what have we got? We have a Docker file. And in that Docker file, you can see we have compiled some exploits. We're actually patching setcomp inside the container. And then we're symlinking procself.exe to the entry point of the container. I should point out that none of these exploits are mine. I'm just standing on the shoulders of giants, of course. And all of these are publicly available. So what happens? We build this Docker file. And actually what we've done in the exploit stage here is actually it's in the other stage is right here we go. So we write the string CV 2019 onto the end of the runC binary. What would we actually do? Well, we just replace it with a malicious payload, like a file or a bash script that did something that we wanted. So how do we prove that this hasn't yet worked? Let's have a look at where runC is. And we see at the end there is nothing there. And then if we just run this container that I built earlier, you'll have to trust me. Then what are we going to see? Nothing. There we go. So these are the return code for the system calls. And we have appended our string. So again, what's happened? We're inside a container, a theoretical isolation boundary, and we've been able to influence or impact things that sit on the host. This is a bad day. This is how we break out of containers. What is the fix here? Don't run old versions of software. Really, really easy. But as we know, everything's a people problem, and our organizations probably mean that it's very difficult to keep things patched in a timely manner. This is immutable infrastructure. This is aggressive builds and pipelines for all of our work, for all of our servers. Onwards. Right, what have we next? Yeah, we've done that one. Yeah, here is the lesson. Patch your hosts. We can use, so we can use GOS to test for kernel parameters, to test for the output of bash scripts, to test for everything, and we can use it in a sly way. And one of my favorite quotes from our esteemed track hosts, containers are a user space fiction. I love that, and you will notice containers don't really exist. Let's not forget we are still in the host kernel. We are still poking around on the same machine. We don't have this we don't have a virtualization as we would do with other containers, collection of stimuli and restrictions born from unintelligent design and years of evolution, a lot like consciousness. Is there a lesson here? No. But everything on the internet and in our organizations is held together with string and sticky tape. We should test everything because when it gets changed, we need to maintain the same behavior as we had before. We're doing this for ourselves. We're doing this for future us. We're doing this for the maintainers of the system that don't even know who we were. We're doing this because we are good open source citizens and colleagues. And we're putting a security test suite in place to help it. So testing is a dark art. It is a software engineering discipline. We need rigor. We need objectivity. Anything can be a security test. What do we do? Arrange, act, assert. Prepare the environment, perform some sort of execution and capture the result, and then assert that it's actually worked. Prove it failed as expected. This is very, very important when writing tests. Otherwise, you've just got a green test suite that doesn't actually catch anything. And beware acceptance testing. Okay. DevSecOps, hooray. Yeah, let's just carry on because we're a bit pressed for time. Testing update versions. All right, GOS again. This is an example of how to paste an animated GIF as a GIF. All right, well, never mind. There is a link there for GOS. Basically, it's very easy to build like GOS test suites. I love them. Testing is cool. It's the only way we can prove that we're secure, but we're not proving the absence of bugs. We're not proving that the system is actually secure. We're just saying for our particular model of it and our understanding at this point in time, it conforms to some level of security. Okay, but that was too easy, right? Let's find some public clusters and pwn those. Right, and then clusters in the wild. How many insecure Kubernetes hosts do you think we can find in a few seconds? 10? 100? 1,000? Very good. It'll be a lot. Let's go Okay, this is, yeah, right. I have my head of security to thank for that. Right, this is Binary Edge. Binary Edge is showdown for infrastructure. This search term finds open Kubernetes. It's not a nice day if you're on this list, where are we? See, this is actually a web page. Let's go back to this. This may not be legal in your jurisdiction. Alert. What Binary Edge does is it connects to unauthenticated API endpoints. That is a gray area. So take this as you will, but the platform has already scanned the IP4 address space for us and then poked at what it has found. We can see up here, that is the query. And down here, this is some Chinese honeypots, action cluster, who knows? I wouldn't touch it with a barge pole. So here is one I pwned earlier. Let's go down here. Well, now. Okay. So let's still on these. So let's test the API server and see if it is leaking anything useful. This is an Nmap script that runs in the Nmap scripting engine. Let's go back up here. And so Nmap Cube API server. I run this with a little bit. Yeah, so all we're doing here is, I'll show you. Not that. What's that? I can't even read it. Okay. So what we've done there is we've looked at a certain port, we've checked for an HTTP response and run a regular expression over it. The regular expression matches git version, git commit, and we can see here that the API server, the Kubernetes API server, is leaking its version information. You would not do this with Nginx. You would not do it with Apache. We learned this lesson a long time ago, but evidently Kubernetes is better than us. Where are we now? Well, what do we think we can do about that version? Any ideas if we can attack it? Well, 1.11.4 has one of the mother of all CVEs associated with it. It is it's poor error handling in the MTLS server. Essentially what happens is a WebSocket connection is instantiated that is bundled in a TLS pipe, if you like, so the encryption is established and then the WebSocket communication goes over that. There was incorrect handling of the WebSocket error code, so the tunnel would stay open and we could then send whatever commands we wanted through. This was initially the most extreme remote code execution. Actually, it's scoped to reflective APIs and it's a little bit more difficult to exploit than we thought about, but let's try anyway. Okay, so what we've done we have here. Okay, so first of all, we will just run this. So we can see we're not actually running the exploit, and as such, we have, and all we're doing here is opening a socket and sending this WebSocket upgrade connection 6 times. But it's not handled correctly because we keep on sending it and exiting. If we then say that we will exploit this to run that piece of code, you'll see that what we have at the bottom, which is 403 forbidden, magically becomes a 200 OK, as we have an unauthenticated request handled by the API server through that connection. This is exploitable, but a bit more difficult, and I will leave that as an exercise to the reader. 7 minutes. Okay, we can now watch it burn. We can run some Monero. If we actually got pod deployment access, we could deploy Monero miners or change cluster creds, or delete all the nodes. So more lessons. Don't run a public API server endpoint on the internet. It's a privileged API, and zero trust does not mean just trust everything is infinitely secure and all our authentication and authorization mechanisms just work. They don't. We would layer ourselves in any other situation. Tinfoil hats are cool, and Moss knows best. If you need another reason why not to run a public API server, you may have heard of this attack. Thanks to Rory McCune, Brad Giesemann, and Ian Coldwater for bringing the honk on this one. This is essentially, it's a fork bomb for YAML. It's like a zip bomb. It's eternal recursion. It will exhaust our API. It should be noted that any string will do in data key A, but honk has been emphatically recommended by the authors. Another open API moral. Zero trust, trust but verified, mutual cryptographic authentication does not preclude the existence of other bugs. And of course, we update and we keep ourselves the hell offline. Okay, let's see if this one will be done in how many minutes I have left. Again, I may suffer. Where am I? Oh, that's another API server test. So, try that again. I don't know why that failed. Yeah, of course, we can write tests for everything and anything that we can programmatically do, and this is just a test for the presence of that. And we don't care so much because we're now on the billion laughs. Okay, so what do we have here? So this is my nice server, and I'm looking for something that I've now lost. Here we go. So we'll run. Time to do this. We'll run that data so we can actually see something going on. We'll check the API server logs, we'll watch events, and we will basically just fire loads of requests. I can't see what that says. So we've got an exploit here which is just going to run this. Let's actually look at that as well. So all we're doing is sending this self-subject access review, which says, as an unauthenticated user, if I was this user, what would I be able to do? That is not an authenticated API call. We send our payload, billions of honks, and we are just doing it again and again and again, which is what the try medium prefix is on this. Let's now source it. Okay. So we'll come back to this in a minute, but what we will start to see is the API server exhausting its threads, failing its health checks and restarting. Because we keep so many sockets open doing this, that is the end of the API servers. Even if they're load balanced, there is an asymmetrical data flood in this attack. They cannot handle the amount of recursion necessarily to infinitely recurse, unsurprisingly. So we will keep on going, if indeed we have the time. Unfortunately, I just started again. That's not what you want to see. Testing, testing. Arrange actor cert for network infrastructure. Well, we've built a tool, a control plane. NetAssert is highly parallelized Nmap. These slides are available later. We love batch core. I am the only maintainer left on this project. Please join me. It's useful assertions for bash. We've built some extensive and expansive test suites with that. It's brilliant. Who runs Istio in the room? A few people. This is for you, especially you, sir. Okay. Istio threats, we did a lot of threat modeling around this. There's lots of stuff that can go wrong with Istio. We don't use the pod security policy because it just doesn't let us configure it. So we have to use OPA. Let's attack the mesh in the last 2 minutes. Okay. So what have we got here? What number are we on? API server. What's that? Oh, that's... I think I may actually be out of time, but... suffice to say, there is no endpoint security. You can hit localhost 1500, triple quit, you can post to it, and this issue will explain how you knock yourself off the mesh. It is going to be fixed. Let's just start by making the administrator reinterface and recursively correct ourselves. We are almost there. How do we evade detection? We stop the API server emitting its audit logs. We black hole traffic. We get in the way of the endpoint. We deny the service the endpoint. We route the cluster, and we turn them off. Nice and easy, deal with in Kubernetes, hacking in a safe space. How do we teach everybody the extreme amount of content I've packed into 30 minutes with this tool? My time is up. It teaches you all of this stuff, and it's really great. This is all wonderful. Test everything. Very unexpected. Wonderful. Thank you very much.